Okay friends, so this is a very important example that I want to show you of finding the IR active vibrational modes of pyridine. To find out the IR active vibrational modes, we need to find out the reducible representation. We need to find its components, right, as we found out in the previous video. Then we need to find out the specific vibrational modes, right? And from those vibrational modes we need to find out the IR active. So this is like the ultimate example, from the reducible representation to the finding its components, to finding the vibrational modes, to finding the IR modes within the vibrational part. So we'll go step by step and we'll solve it. Okay, so first of all, to find out the reducible representation, we need to know some facts, as in how it's found out. So first we'll write out the elements over here, that is E, C2, sigma V and sigma V prime. Okay, so we need two things on this side. One is contribution per atom, okay, and one is the unshifted atoms. So contribution per atom, for E it's always 1, for sigma it's always 1. For C2 the formula is actually 2 cos theta plus 1. Over here we have C2, so it's cos 180, which is minus 1, so minus 1 into 2 is minus 2, plus 1, which is minus 1. Okay, so let us look at the pyridine molecule. So we have the C2 coming from this side, as well as the sigma V. The sigma V prime can be thought of the molecular plane, because this is the second sigma V that's given. So for C2 and sigma V, we can see we have 3 unshifted atoms. So we'll just write 3 over here. For E and sigma V prime, we have 11 unshifted atoms. So we'll just write 11 over here, and we will find out this multiplication, which is 11 minus 3, 3 and 11. So this is our reducible representation. Okay, so just one small correction over here is that the contribution per atom for E is actually the basis, the dimension of the axis we are taking. So over here we took like a 3-dimensional, or a basis is X, Y and Z, so it's 3. So over here we'll have E as contribution per atom is 3, and this is our final reducible representation, which we get by simple multiplication. So first step is done. We have got the reducible representation. Now we need to find the components it has of the irreducible representation. In the formula we know we used in the previous video is this, right? And if we do it and find it for A1, right, so the order of the group is 4, and we have over here, and all the symmetry order of the group is 4 because all the elements are occurring 1. So 1 over here we have 1 plus 1 plus 1 plus 1, which is equals to 4. And since all are occurring 1, so G is 1 for all, and we are just multiplying the characters of the reducible representation and the irreducible representation in all the 4 cases of E, C2, sigma V and sigma V prime. We have already done this in previous videos, so I'm not going into details, and the answer over here will be 11. Similarly, we'll do it for A2, B1 and B2, right? So you can watch the previous video if you don't know how to do it. And the components of the reducible representation which we'll get finally is reducible representation is equals to 11 A1 plus 4a2 plus 7b1 plus 11b2. So our second part is also done. Third part is we need to find out the vibrational parts out of this. So how do we do that? Now listen to this concept carefully. For translational modes are the ones which have X, Y or Z along it. So over here we have to see on this column, right? Which are X, Y or Z, and rotational are the ones which have Rx, Ry or Rz along it. And vibrational, what we do is we take the reducible representation which we just got and subtract all the translational and the rotational from it. So this will be equals to 11, this whole thing that we got just now. Okay, this whole thing, let me represent it as by, suppose this is I represent it by a star in a bracket. Okay, so I have this star and I subtract the translational part from it. Translation part over here we can see like Z over here, X and Y. So which are the ones? It's A1 plus B1 plus B2. And the rotational ones are which ones? Which have Rx, Ry and Rz. So it's A2 plus B1 plus B2. A2 plus B1 plus B2. So what do we finally get over here? I'm writing it over here. The final solution which we get from this calculation is 10A1 plus 3A2 plus 5B1 plus 9B2. Okay, it's a simple calculation actually which we have done. So we have got this part, and now what we will do is, so the third part is also done. So now we have to find out the IR. Now again listen to this concept carefully. For IR, active modes are the ones which have X, Y or Z along it. And Raman active modes are the ones which have a quadratic one, like suppose x square minus y square, or even things like xy or xz. So over here we have the ones, so which ones are IR over here? The ones which have A1, B1 and B2. So out of the vibrational ones which we got, so how many vibration did we get? We got 10 plus 3 plus 5 plus 9. This is equals to 13, 18, 27. But A2 is not IR active, as A2 does not have X, Y or Z, right? So we'll subtract 3 from here, which represents for the A2, and we'll get 424. And we have 24 as an option over here. Okay, so the number of IR active modes, IR active is equals to 24. So this was a big example, but a very conceptual one. A very brief summary of this is we take pyridine, we draw it in its full form. Okay, so here I think you cannot see the H. So we have actually 11 atoms over here. Found the reducible representations from it, and we see the contribution per atom. This is actually a theory behind it. Okay, so the contribution per atom into the unshifted atoms, we get the reducible representation. Then we find its components, as we learned already before. From the components we find out the vibrational ones, and out of the vibrational ones we found out for IR active and Raman active. So that was it. It's a very important example, and do go over it again and again. If you get some more examples, do practice. It will be very beneficial. So thank you, and do subscribe to the channel if you haven't done it. and God bless you.